everyone. Thanks for being here today. I'm Chris Hines, Product Marketing Manager at the company, and I'm joined today with a special guest, our security lead, Nathan, my colleague. So Nathan, thanks for being here.
Hi there. Hey, everyone. This is Nathan. I'm really happy to share with you some of the stuff we've been working on lately, so let's go ahead and get it started.
Sure, and today we're going to be talking about how to actually go out and achieve safer apps with Docker. So just before we kick things off, just a reminder here, this presentation is being recorded, right? So what we'll do is we'll follow up later this week and share the recording with you. You can give it another listen. You can share it with anyone that you'd like as well. Also, towards the end, we'll save some time for Q&A. So you have the opportunity to ask questions. You can post questions throughout the presentation using the WebEx portal here. Just know that we won't start addressing them towards the end. And with that being said, let's go ahead and kick it off. So one thing I did want to remind everyone of is that DockerCon 2017 is coming up. Right? If you aren't familiar with DockerCon, it's our big user conference. This year, it'll be hosted in Austin, April 17th through 20th. And as a special thank you for being here today on the webinar, we're offering a 10% off promo code. So you can go and use promo code HINES, Hines, and you'll receive 10% off the DockerCon pricing. So last year, we actually hosted a survey called the State of App Survey, and we interviewed 500 IT ops and developers, and we found that Docker was really involved when it came to these three key initiatives taking place within the enterprise. The first one was app modernization, right? When you look at a monolithic application and placing it within the container to recognize some of the portability, security, and cost savings that come as a result of that. Another was cloud. Right, when you look at organizations looking to adopt cloud strategies like hybrid cloud or multi-cloud, they're using Docker to help them do that. Right? In the survey, we found that 80% found that Docker was key to that initiative taking place within their company. And then the third piece was DevOps. Right? Think of DevOps / CI/CD, right? Like looking to break down that traditional barrier that has existed in the past between developers who are building applications and IT ops teams who are looking to manage and deploy and scale applications across their standard platform. So to do that, we've created a commercial platform here called Docker Datacenter. So if you're not familiar with Docker Datacenter, it's our on-premises solution. It delivers an end-to-end container management solution. Right? So here's a quick look at the stack here. Right? It runs on the engine itself. Of course, the Docker engine can run on any infrastructure, right? Public cloud, VM, or physical. And the Docker engine itself has a lot of kind of cool features and capabilities built into it. It's the runtime, right? The thing that creates and runs the container itself. But we've taken things like Swarm, our orchestration solution, built that directly into the engine itself, as well as providing some networking and volumes plugins. Docker Datacenter includes this on-premises registry, right? The place we actually store and secure your image content. And I know Nathan will talk about some of the security features that we have baked into the overall platform later on, so I don't want to steal any of his shine. Just know that that's a key component baked into this platform. And then, of course, the management layer, which is kind of how your IT ops folks go into like this GUI managed atmosphere, and they can manage their nodes and their applications and scale them and deploy them and what have you. So with that quick overview, I want to kind of walk through what the end-to-end flow with Docker Datacenter looks like, right? So this is, if you will, the Caas workflow. We talk about build, ship, run here a lot at Docker, and this is kind of a snapshot of what that looks like in the context of Docker Datacenter. Right? So you have the build component. We have your developers who are using like a Docker for Mac or Docker for Windows to build an application, right? Build that image and then push that image to a registry. In this case, Docker Trusted Registry, where it's stored, it's secured. Right? There's some like a signing and scanning component that Nathan will talk about later on. And then that ship piece here in the middle serves as really that central kind of location, that centralized location where developers and IT ops really mingle, right? So you have the developers who are building the app, they push it to the registry, and then the IT ops team can then go into this registry, pull it, and run it in production. And it also gives the IT ops teams the ability to kind of control what's in the registry itself, because IT ops teams can determine what images are safe for use, and then developers can use that as a secure baseline when they're initially building their applications to begin with. And then, of course, the portability of universal control plane and the containers themselves allow teams to deploy them in the cloud or on-prem, and have full portability between those environments as well, so to avoid things like being locked into specific infrastructure. So that's a quick overview of Docker Data Center. At this point, I want to transition over to Nathan, and he can talk about some of the key security components within Docker.
Hi, everyone. So like I talked about earlier, we're kind of going to be talking about container security overall with kind of a particular focus on something we've rolled out pretty recently called Docker Secrets. So I guess just to kick off, kind of set the frame for how we think about security, kind of the way we kind of measure every security initiative that we do here at Docker is against these kind of three key themes or axioms that we kind of consider fundamental to how we build security at Docker. The first one is usable security. Usable security really has two components. The first thing is secure defaults whenever possible. You should have a secure default so that just out of the box it is in the secure configuration. And then beyond secure defaults, usable security also comes down to natural feeling tooling that works well for developers and for operations teams. It should feel natural. It should feel like a natural part of their workflow as much as possible. And if we're able to do that, then security will actually be able to be achieved within organizations. The second key theme is trusted delivery. There's a bunch of stuff that's needed for an application to get delivered to an infrastructure. There's code, there's configuration, there's secrets. So any of these things that might get delivered as part of an application being able to run in whatever infrastructure it is targeting, it should all be delivered in a secure way. And what I mean by that is in the case of something that absolutely must be correct, say it's code or configuration, things like that, they should be signed. If it's something that's secret, if it's sensitive information, it should be stored and delivered in an encrypted manner so that there's no possibility for interception at any point. The third key theme that's extremely important to us is infrastructure independence. As much as possible, and indeed everything I talk about today, are things that are available as part of the platform, not as part of any hardware or any cloud solution provider that you're deploying in. Everything is built in a platform native way so that it works across VMs, cloud infrastructure, your own bare metal infrastructure. And when you take these three key themes together, and if you kind of use that framing for all the features you build, you end up with what we call safer apps. So apps should be safer when they're deployed in Docker containers, and I want to talk a little bit today about how we do that. So maybe just to dwell a little bit on this slide and kind of look at some specific incarnations of some of these themes within our platform. In usable security, kind of one of the best realizations of that is the Application Secrets Management solution that we've just rolled out in Docker 1.13.1. And I want to go into depth on that for the rest of this conversation. So for now, I'll just kind of leave that as a teaser. The other kinds of things we think about with usable security are that dev and ops workflow. Again, having a notion that Docker containers really span that whole build, ship, run lifecycle, and you're able to embed and have a natural feeling security workflow at every part of that infrastructure. And finally, kind of the linchpin of Docker security is the secure by default runtime, which we won't spend a bunch of time on today, but it has done a very good job. We've done a lot of work to take every isolation feature of the Linux kernel and do the work to come up with a sensible default that targets the microservices and legacy kinds of applications that people are deploying on containers. So we've done a bunch of work there just to give everyone that default usable security that they have. Moving down the chain a little bit, we're talking about trusted delivery and the kinds of things that we do in terms of trust delivery. So one of the most important things that comes to mind is image signing and verification, which is available in Docker Content Trust. That ability to say, hey, this is the producer of this image, and I only want to allow trusted producers of images, trusted authors of images, to actually deploy images into my cluster. Same story for image scanning. Image scanning is super important to figure out what's in the image, what the security characteristics of the image are. In some sense, you can think of this as the advice we all got from our mothers growing up. It's what's on the inside that counts. So looking at the contents of the image, really deeply understanding what the security ramifications are of anything that's in there. Finally, in trusted delivery, we also think about like implicit properties of the platform, like providing encryption at rest and TLS encryption across the board. Anytime sensitive data is stored, it should be encrypted. Anytime it's sent over the wire, it should also be encrypted. And then finally, the notion of infrastructure independence, where all of these security characteristics are available whether you're on physical hardware, virtual hardware, or public clouds. And then for Docker Datacenter users, being able to manage users and role-based access control in a cloud-independent way. Kind of have your organization doesn't change when your cloud does, and so your management of the users shouldn't change either. Again, all in service of this notion of creating safer apps, enabling apps to be safer when they're deployed inside of Docker. So kind of moving on and digging into that a little bit, I put Iron Man on the slide because that's really the way we think about it. We think about it as the same way Tony Stark is an intelligent, good-looking guy, but when you put him in the Iron Man suit, he's more secure. He has more power to secure himself and to protect himself. That's how we feel about the Docker platform. You take an application with all of its creativity and the unique offering that it has, you put that inside of the Docker platform, it becomes more secure as a result of being in the platform. And in fact, Gartner has kind of backed us up on this in some recent analysis and advice they gave their customers. They've said explicitly apps are safer in Docker containers. So we're actually seeing a lot of folks start to understand this, and it's something that we're going to continue to invest in. Speaking of continuing to invest in it, in the same way that the Iron Man suit evolves over time in terms of it gets more features as the movies progress, or as Tony Stark invents more features for it. The same can be true for the Docker platform. We're adding security features as we go. There's a secure baseline that we've built up so far, and now we're looking to add additional features to help give those additional capabilities. And one of the most important additional capabilities is having a sane and secure secrets management story. So let me dig into a little bit about what I mean by secrets management. In order to understand this thing that we're managing, let's talk about first, what is a secret? Why do we care? And one of the best ways to think about it is to reason by analogy to humans. So in the most basic level, humans are to passwords as applications are to secrets. Humans have say a Gmail password, a Facebook password, maybe a password to log into their phone. Whatever the case may be, there's secret information that humans need to manage in order to authenticate to services. It's the same story with applications that are deployed within everyone's infrastructures. They have a bunch of secret information, be it encryption keys, auth tokens, TLS certs, that are necessary for them to perform their function, and they should be treated securely delivered, and have a good policy on how to access those. And in particular, the application should be the only one who gets access to the secrets. Take, for example, someone that lives in an apartment complex. If you live in an apartment complex, that shouldn't automatically mean that you get to know all of your neighbors' Gmail passwords. Same story with applications. Applications that are deployed in the cluster should only get to know the secrets that they need. They shouldn't get to know all of the secrets in the cluster. So we're going to talk a little bit about how we've done this, but in kind of summary, what we announced last week was the first container-native secrets management solution. We've kind of architected and built into Docker a secure secret management solution that really embodies all those themes that I talked about earlier. Usable security with the dev and ops workflow that I'll go into later. Trusted delivery, and that everything is encrypted, whether in transit or in storage. All built in an infrastructure-independent way. You can use this whether you're deploying on your own hardware, on VMs within your own infrastructure, or across arbitrary cloud environments. All of the security properties that you get of the system are inherent to the platform and can move anywhere you want. And in terms of making apps safer, we really achieve that objective that I talked about on the last slide, which is there's no way for another app within a cluster to be able to see the secrets. Only the exact secrets that are assigned to an app are the ones that they can read. An app can't read another app's secrets. If you take a step up and then look at our Docker Datacenter product, our Docker Datacenter product takes all of the open source stuff that I'm going to go into and adds role-based access control, where you can specify within your organization which developers or IT operations team members are able to manage secrets, assign secrets to services, and specify the workflow for secrets. So that granular access control, the role-based access control, and like Active Directory and LDAP integration is all available within the Docker Datacenter product. So with that, I actually want to dig into a little bit about the existing solutions and where they excel and where they might fall short. And to talk about existing solutions, the first thing we really have to talk about is like what happened before Docker. Before Docker came along, kind of turned the application delivery mindset on its head. What were we looking at? In a lot of cases, what we're looking at is what we'd basically call static configurations. An application got deployed on a host or maybe deployed on a VM and kind of lived there for weeks, months, even years. And so for a lot of folks, what they were able to do is just copy the secrets there and have them consumed by the application directly on whatever piece of hardware or virtual machine instance was necessary. But as I said just a little bit ago, containers turned that notion on its head. With containers, you might have a container on a host for a matter of hours or maybe even down to minutes, and then it moves to another host. There's kind of this dynamic ephemeral provisioning that is possible with containers. And so that necessitated a new kind of solution to a new kind of approach to secrets management. And so what we've seen so far is basically people hacking together solutions. And they kind of have a sliding scale of how secure and how usable they are, but none of them quite hit the mark. So let me tell you a little bit about how we see some of these playing out. The first one, probably the worst, but maybe the most common solution is to check your secrets into your revision control. Check them into GitHub, check them into whatever your internal revision control system is. And this is one of those things that like no one really wants to admit. If you talk about it among friends, people will admit that this happens, that they accidentally open source some repo and then their AWS infrastructure was all of a sudden mining Bitcoin because someone found it. Like this happens. It's very common. And I'd say the reason it happens, the reason it's common is because it's easy. Developers are fundamentally looking for that easy-to-use, flexible system to deploy their secrets, and many times that looks like GitHub. So as insecure as it might be, it does fit the usability mark, but we can do better. In service of doing better, there's a lot of folks that have tried to solve the solution at various levels of the stack. So there are things like config management and machine provisioning solutions that kind of deliver the secrets to the host kind of dynamically as the host is being assigned secrets. There are kind of independent secrets management solutions that kind of like are really good at secrets management and have really good properties there, but what they unfortunately lack is the dev workflow where you can have a standardized workflow from dev into operations. So although some of the existing solutions are kind of secure, they often feel bolted onto the side and don't fully utilize the full capability of the platform. Finally, the third category here is probably my least favorite category is other container orchestrators who have basically implemented secrets management solutions that are effectively trivially insecure, in that the secrets are all stored in plain text, they're all sent over plain text, and worse, every application deployed within a cluster can see all the secrets. So going back to that apartment analogy, the existing container orchestrators really act like an apartment where just by virtue of being in the apartment complex, you get to know everybody's Gmail password. That is really the case in some of the existing container orchestration systems. So we really saw that there was an opportunity to do better and kind of set a high bar for what it means to have a container-native secrets management solution. So let me dig in a little bit to how we've done that and kind of some of the philosophies that have gone into building our secrets management solution. The first thing to think about is that we wanted to make apps safer with Docker Secrets Management. We wanted to be the case that if you're using Docker Secrets Management, your application is safer. One of the ways we conceptualize that is it is desirable within a secrets management solution, within an infrastructure at all. It's really nice to have a standardized way to access secrets. If every application within your infrastructure is accessing secrets in the same way, you have the smaller trusted computing base that you need to reason about. You can say, okay, I know every app is going to access secrets like this, so I don't need to worry about different workflows, threat modeling different workflows. You can just say, okay, there's a standard, it looks like this, and it's actually delivered in a secure way, so I'm happy with that. I can think about other problems. The other thing that's interesting about having a standardized interface is that we wanted that to work pretty broadly across the ecosystem. So we want it to work both for legacy apps and microservices. Legacy apps have property that they can't really be changed because in many organizations, the developers that are responsible for these apps may have moved on, so they may not even be there anymore. So you want it to work without having to change any code. Same story with microservices. Microservices want to access secrets in a very easy way and not have to write application-specific code to do that. The other thing that's important to have standardized is dev and ops workflow. I know I've talked about this a lot, but it's really important to us in terms of usable security, in terms of making safer apps, to have something that involves both the developers and the IT operations teams so that they're actively working together to solve this problem. We really think that's the best way to have these kinds of problems solved. So we look to provide tooling that respects the agency of everyone involved in the process. And finally, we want to do the same no matter what OS you're deploying on. So if you're deploying on Linux, you're deploying on Windows, the security properties and the interface ought to be the same. So very important to have that standardized interface kind of across the board. Second notion that's actually really important to us, but it's kind of obvious, is this notion that apps are safer when secrets are not stored in the app itself. Many application workflows are going through a continuous delivery chain where the application might live in development for a while, and then maybe move to a test environment and then onto a staging environment, and then finally get promoted to production. At each stage, the application should be using different secret content, but accessing secrets in the same way. It should be able to say, hey, I want to access foo secret and have it be placeholder data in dev, test, and staging, but then in production have real live data. So just being able to have that decoupling of applications from their secrets, but still having the applications access them in a standardized interface is very important to us. The next notion that's really important to us is trusted delivery. And trusted delivery is actually going to get to some of the specific features of the secrets management solution that we've rolled out. So let me kind of in a brief overview talk about what we care about in terms of trusted delivery, and then I'll actually go into some architecture diagrams that kind of explain this in more detail. The first notion that we care about is that secrets should be encrypted at rest in the cluster store. Any secret that's stored within a cluster store should be stored encrypted. This is in case the disk gets stolen, in case someone gets access to the host. It should be stored encrypted. It's just kind of a good security incident reduction policy to have data encrypted. And the same story for data encrypted while in motion. Anytime a secret is sent over a network call, it should be sent over a TLS-protected network call. That is to say, to be SSL, that should be an encrypted tunnel such that it's never available in clear text within any network device. Third feature, and probably the most important feature, is that the secret should only be delivered to the exact authorized app. It should never be available to another app within the cluster. It should only be available to the application it was assigned to. And fourth, kind of as a bonus feature, something that we actually really quite happy about, is that the secrets should only be available in memory, even when they're deployed on the containers. So this is kind of a hard thing to achieve, and I'll talk a little bit more about how we've done that. But again, keep in mind that we never want to store secrets in clear text anywhere. So we encrypt them for long-term storage in the cluster store, but out in the cluster itself on all the worker nodes, we're going to do all we can to never save those to disk. So let's dig into a couple of these features as we look through this. This slide kind of talks about the default architecture of the secrets management solution. And a couple of things to point out here. We've got a couple of team members. We've got like a blue team and a red team. And I'm sorry if anyone is colorblind, but trust me, there are two different colors here that represent different kinds of secrets. So there's a blue secret and a red secret. And the first thing to say is those are being stored in the internal distributed store in an encrypted manner. They're stored on disk, encrypted, and in fact, the way we do that is that everything within the internal distributed store is encrypted. There's none of that information is stored unencrypted, and then secrets actually kind of get the benefit of that encryption that we added as part of the 113 delivery. Moving to the next slide, we'll talk a little bit about the delivery of the secrets. The first thing to say here is that, as you see, the manager nodes and the worker nodes each have a little lock, and that lock represents the TLS identities. If you remember the Docker 1.12 announcement, we talked a lot about cryptographic node identity, where any machine that joins a cluster is assigned an identity so that it can use that for internal access control and authorization. And so we actually built that in anticipation of wanting to add secrets management later on. And we're getting a lot of benefit out of that because now every worker node connecting to a manager or a manager connecting to a manager, all are connecting over a TLS encrypted, extremely secure channel so that we know exactly where we're delivering secrets, who they're being delivered to, and there's no possibility for impersonation of the different components within the cluster. Second notion to talk about here is to go back to those different keys. We've got the blue key and the red key again, and where I want to direct your attention first is to that worker over on the right-hand side of the slide. That worker was actually assigned two workloads, the blue workload and the red workload. And along with those workloads, the secrets were sent down. And note that it was only the blue secret that was sent down to the blue container, the red secret sent down to the red container. They weren't able to see each other's secrets. There's no way to access each other's secrets via this mechanism. They're just delivered specifically to the container that needs them. And in fact, only delivered to the hosts that need them. So if you look over to the left-hand side, you'll see a worker that only has the red secret, and it only makes it available to the red container. We do it in this manner so that there's never a node that has access to all of the secrets. Only the managers have access to the secrets. This is pretty important as a threat reduction, least privilege implementation. Another way to think about this is to kind of reduction in blast radius. If something awful happened on one of these worker hosts, you never want that to happen. But if it does happen, you want to only lose access to the secret material that had to be on that host already. You don't want to lose more because of the way it was deployed. And that probably the best example of that is this middle worker. The middle worker is running the gray container, which actually doesn't need to have access to any secret information. That ends up being pretty significant because no secrets at all are delivered to that host. It's just a bare gray container with no access to any sensitive information. Moving on to the next slide, we've actually got a pretty interesting slide to talk about a little bit here. And just to kind of talk about the different kinds of secrets that we imagine people will use within Docker Secrets Management. So take a look at the blue key over on the right. It's being used to talk to an external app. So an example of this might be an API token, say to talk to the Twitter API or maybe to the GitHub API, whatever the case may be. And it's used for an external reference. Maybe it's TLS or who knows, but it's some sort of externally used secret. The red key, however, is used for internal authentication. This red container is for some reason talking to this gray one. Maybe it's an authenticated internal call, and that secret is able to be used to talk to the gray container. We're hoping that with a default integrated secrets management solution, companies and organizations will be able to do more internal authentication and authorization within their clusters, just kind of as a consequence of the fact that now secrets management is really easy. We think that applications are fundamentally going to be able to be designed with more security in mind, just by sheer virtue of the fact that there is now an available, easy-to-use secrets management solution. Other thing to talk about here, just briefly, is the way that we expose the secrets into the container. We actually expose them as a file system, so that any application ever written can read the secret from the file. Now you might ask, oh, you're storing in a file, how do you ensure that it doesn't hit disk on the worker nodes? Well, I'm glad you asked. The way we do that is we mount them in a memory file system, essentially a tempfs, that allows us to create a memory, reserve some memory within the Linux kernel, and then serve the secrets as if they were files into the containers. So this allows us to make sure that the secrets never show up on disk on the worker hosts. Pretty important feature, both for preventing preventing secrets from being stored anywhere, and for legacy apps to be able to use them, because as we did a survey of the easiest way to implement or integrate secrets management solutions, we found that basically all software expects to read a secret from a file. So file system interface was the natural consequence of kind of looking at that data. Moving on a little bit, I want to talk about infrastructure independence. I know I've covered it a little bit, but it's actually really important to us, so I want to dwell on it a little bit more. There are many solutions to some of these problems that are dependent on a specific piece of infrastructure. Take, for example, the encryption that we did in the Swarm cluster. We could have instead decided to work on, say, encrypted disks and say, okay, you need to use encrypted disks if you want encryption of your secrets within your store. We found that unacceptable, though, because, again, we want to have usable default security available to everyone. Same story with the secrets management solution. There are a number of cloud-specific secrets managers, but we wanted people to be able to have a standardized interface that they could use no matter where they're deploying. So they can deploy within Amazon, within Azure, or on their own private cloud without needing to rewrite their apps to expect some sort of different key management solution. So very important to us that the security guarantees travel with the application across the infrastructure where the application is deployed. Finally, I want to talk a little bit about usable security. Again, this is something that's very important to Docker in general. Usability is kind of one of the main reasons people are attracted to Docker, and we can't mess that up with security. We need to be just as obsessed with usability with security as we are with all other aspects of usability. And what that really meant here was creating a standardized interface that basically provided a very simple interface for developers, but then the same simple interface for IT ops, but an ability to gain secure policy management on top of that simple interface. Let's talk a little bit about what the simple developer workflow is. I'm sure many of you on the call, if you're Docker users, if you use it for any amount of time, you've probably used a tool called Docker Compose. And what Docker Compose is, for those who may not be aware, it's a way to run your applications kind of locally on your laptop and spin them all up in a cluster and kind of like test them in development. What we've done as of 1.13 is implemented Compose with Docker Swarm mode so that you can deploy Compose files into swarms. And as part of that, we've added secrets management. So there's now a top-level primitive within the Docker Compose file that allows you to programmatically specify secret slots, essentially. You can say, hey, I'm going to need a secret named this. Please give it to me no matter where I'm deployed. So in development, you might get a placeholder secret. And then in production, when you move on to Docker Datacenter and use the production infrastructure, you might end up using a different secret. You might use one that was specified by a IT policy management person who maybe made a larger secret or just wanted more fine-grained access control to that. But the application didn't have to change. The application was able to be exactly the same no matter where it was deployed. Docker Datacenter provides other features as well, things like access control. So you can say, for example, maybe you have some very sensitive secrets that need to be available to only a small set of the engineering team. Maybe it's because they're responsible for encryption, decryption of very sensitive data, or they're the keys used to do significant money movement. Whatever the case may be, you might have some secrets that are more sensitive. And you may also have some keys that are less sensitive, kind of widely available, maybe a cookie validation token, something like that that's kind of broadly available to all the apps. All the apps kind of need it because of some standardized interface they have. So you might make that secret available to a wider portion of the population assigned to more services. So all that is possible with Docker Datacenter, but none of it detracts from the default security that was built into Docker 1.13.1. Now, kind of in summary, I've gotten to talk to you a little bit about secrets management and how we think about that, how we think about it in the entire system. There's plenty more to the Docker security story. This doesn't cover nearly all of it, but I wanted to just kind of do a deep dive on that and really kind of help folks understand how we really want to help as much as possible safeguard applications across any infrastructure and really make it the case that with Docker, your apps are safer. With that, I'll turn it over to Chris, and then we'll have some time for questions.
Awesome. Thanks so much for that, Nathan. I appreciate that. So I know we talked about Docker Datacenter a lot here. What I wanted to do here was kind of talk about the 3 ways that you can actually start getting access to the platform itself. We offer a free 30-day trial, and that trial gives you access to, universal control plane, all the Docker Datacenter features that are available. And then once you've trialed it for 30 days, you test it out, see if it works for your environment. There's 2 different support levels. So there's business day support and there's business critical. Currently, business day, the sticker price is about $1,500 per node per year, as well as, and then business critical is about $3,000 per node per year. Again, the difference is business day being 9 a.m. to 6 p.m. local time, and business critical being 24/7 support. So here's our information here, but what we'd like to do is open up the floor to questions from the audience. I know several have come in now. What I'm going to do is take a look at some of these. We can address as many as we can. Let's see. Bear with us.
So the first question is from Anand Moria, and the question is, around encryption at rest, are you saying that all the REST calls originating from the Docker can be encrypted automatically? Yes, that is what I'm saying. You can, certainly within the cluster, any communication within the Swarm cluster itself, either from the manager nodes or the worker nodes, is automatically encrypted. Relatedly, whenever you're going to add a secret, you can specify to connect to that TLS port on the Swarm manager and specify the secret in that way. So even from your machine connecting into the Swarm cluster, it can be over a TLS connection. That's right. Yep. We got a question. Can you clarify, is the secrets management system available only with Docker Datacenter, or is it available in the open source version as well? This is a great question. All of the secrets management as a secure implementation of secrets management is available within Docker 1.13.1. So that's all available within the open source. Everyone can download it and try it out at your leisure right after this call. What's added with Docker Datacenter is the ability to have role-based access control for your organization interacting with a cluster. So who within your organization can access which secrets, who within your organization can assign which secrets, all of that's within Docker Datacenter, in addition to the management plane and UI that's available within Datacenter, kind of that whole integrated ability to kind of manage everything within a single UI. That's all part of Docker Datacenter.
And another question I have for you, Nathan, that came in from Elotron is,
yep.
Will Docker Content Trust be made more usable, especially with regard to delegation in a future version of DBC?
It's a great question. Yeah, so the baseline Docker Content Trust implementation with using delegations within Docker Datacenter, right now it works, and folks can actually do pretty powerful things in terms of setting signing policies where you can say something like, I want to make sure that this image passed CI, passed a security scan, got promoted to staging, and only if I know that it's gone through all of those stages will I allow it to be promoted to production. In particular, we have a cryptographic guarantee that the CI system signed off on it, that the staging system signed off on it, the security scanning system signed off on it, and only if you have all 3 of those signatures can it be deployed into production. Now that said, it's kind of rough at this point. It works, but it's a little bit of a power user feature at this point, and we're actively working now on making that more easy to use, so that's more available to everyone. We weren't quite able to nail the usable security there, but we knew that it was a request from us customers that we wanted to at least make it available out of the gate.
Cool. And now I see a couple questions that have come in around access to the actual slides and the recording itself. I mentioned earlier in the beginning of the presentation that yes, this presentation is recorded and we'll be following up later on this week via email, so we can share the slides as well as the actual recording to this for you if you'd like. I see a couple questions that are still coming in here. One around security bench.
Sure.
I use this is for Patrick. I use Docker Security Bench. I'm asking myself how I can fix this issue. So restrict container from requiring additional privileges in general. He'd love to see a security bench, how to fix manual, maybe. We have more resources on that.
Yeah. So it's a good question. A lot of that actually, restricting a container from getting additional privileges, a lot of that comes actually from the platform itself. So the cap dropping access control there. I'm not right off the bat familiar with what 5.25 is. So actually what I'd ask you to do is, if you have a specific question about that, is you could file an issue on the Docker Bench repo. We could help out more there and kind of direct that question to some of the engineers who are working on it. That'd be pretty helpful. I'd love to help you out there.
Questions coming in. All right, Patrick, thanks for the feedback. I'm glad we addressed that one for you. Here, a question around Docker Compose.
Sure.
From Doug Topham.
All right, so on Docker Compose, what is a good method for conveying the actual Docker Compose file along with the images that were built? By that I mean the DC file is necessary for use by operations, for example. So need to also be attached to a ticket or something that is related to the image being deployed. So this is a great question. The fundamental question here is, how do I share my Docker Compose files so that they're usable by other folks? So right now, it's basically like, how do I create almost like a distributable Docker Compose file to share among people? There's been experimental work in this area around something like dabs or stacks, and kind of making a multi-container application usable by other folks without having to use a Compose file. There's active work in that area. I'd say expect that to come in a later Docker release. For now, the best way to do it is to share the Compose files, maybe through a GitHub repo, or in Docker Datacenter, you're actually able to copy and paste a Compose file in. We know it's not ideal, but it kind of works for now. But this is kind of an active source of design at this point, so follow the repo closely. We're looking at ways to make that better.
Cool. I'm looking through. I don't see many more questions. Let's see what popped in. If there are more, please feel free to post them. All right, here's a couple that have come in.
Okay.
How do I easily clean up unused images?
So I think you'll find, if you read through the release notes in 1.13, we've actually implemented a new command that helps out with that. I think it's called Docker Prune, that kind of helps out exactly in that area. I think you'll be pretty happy. It's basically going to do exactly what you want.
There's also the feature, the garbage collection feature within DTR.
Yeah.
So like any orphaned images, you have the ability to just do a hard delete of those.
That's right.
So I can take this one. What's the definition of a Docker data center node? So that node could be a cloud instance, right? So per cloud instance, per VM, or per bare metal server, right? So the only note with the bare metal fact is that there's a limit of 2 CPUs. Once you exceed 2 CPUs for the bare metal piece, then there would be an additional cost. So that's the definition of the data center node. Think about it as like one engine per node, so per engine. Let's see. So this is around Docker Compose file, I guess within UCP, part of DDC. So how do you copy the Docker Compose file into DDC?
So in the latest version of DDC, you'll probably need to update to the latest version. It's based off of 1.13.1. There will be a UI that you can copy and paste it into.
Sure. A question for Martin is, where can I find documentation on secrets directive in the Compose file?
Good question. It should be available within the Docker stack command on the docs page. I don't know exactly where the link is, but it should be available within the standard Docker documentation that's available as part of 1.13.1.
Yep, and part of the follow-up, I can find that link and send it out, or I can, if you have a few minutes to stay extra, I can post it in the chat here and make sure you get that link if you require it. How easy is it to upgrade Docker Data Center? I know there's docs out there, so docs.docker.com, which kind of walks you through how to actually go about upgrading to with 1.13. if you need that. So it would be doc.docker.com would have that information for you. And I think that's all the questions we've gotten through. Does libcompose support the secret management capabilities? I don't know that personally.
libcompose does not support it.
Okay. I think that's all the questions that have come in. So I know we have like 10 minutes more, but I know 50 minutes is kind of long, right? So I want to take this moment to say thank you to everyone who's here in the audience for being with us and listening on the presentation. And of course, a special thank you to Nathan, our security lead here, for walking us through the presentation.
Yep. Yeah, thanks everyone for joining. I'm definitely available on the repos. You can email me at nathan.mccauley@docker.com. Happy to help out in any way to get folks using this. So thanks a lot for the time.
Thank you. And I saw one more came in from Charlie. I can take this one. Will CVE scanning be covered? So Docker security scanning was something that we also released. It's now available as part of Docker Datacenter. So the answer to that is yes. For those of you who aren't familiar with Docker security scanning, it's a way of doing a binary level scan of the layers within each image. And it's actually baked into the registry component. So there's a GUI. You can scan an image, and there's a whole kind of profile that's baked out and on a layer-by-layer basis, which shows you anywhere from major to minor vulnerabilities that are within the layers of an image. And there's also this concept of continuous monitoring, where we use webhooks to alert you, where you just have like a webhook receiver, and we can alert you of any new vulnerabilities that were found. So your team can go in and take the necessary action to either fix those vulnerabilities or at least kind of be aware of them, make the best use out of them, if you will. So yes, Docker security scanning is available. And I think with that being said, it's a good point to close up. So again, thanks everyone.
Thanks.
And, look forward to have you join next time.